Hello, in this video we're going to go through question 10 from lesson 5. This question says triangle ABC is right angled with A 1 1, B negative 2 3, and C 3 4. We want to find which angle is 90 degrees. So what I've done already here is I've drawn a diagram, and it's a scale diagram, and I can see pretty obviously that angle A is in fact the 90 degree angle. However, let's consider cases where the diagram is not as easy to draw the diagram. So we have to use some algebraic arguments here about looking at what is a 90 degree angle. So there's a couple ways you can do this. One way to do this is to use the length argument. And what I mean by that is I'm going to find the length of each side. I'm going to find A, B, and C. And so notice, if this is vertex A, the opposite side is called small a. If this is vertex C, the opposite side is called small c. And this is vertex B, the opposite side is called small b. So I'm going to find ABC, and then what I'm going to do is I'm going to plug them into Pythagoras' theorem and see that it works out. Now be cautious here. Often we learn Pythagoras' theorem as a squared plus b squared equals c squared. And students by habit will just sub it in that order, but watch, C is not the hypotenuse here, so really be careful of that. So let's find these lengths. So let's find length A, and I'm not going to go through the whole plugging into the distance formula. I'm going to read it right off the diagram. So we see we go up 1 and across 1, 2, 3, 4, 5. So we're going to have 5 squared plus 1 squared, and so we're going to get the square root of 26. And at this point, I'm not going to plug that in my calculator. I'm just going to leave it like root 26. If I have a reason to change it into a decimal, then I'll do that. Now we're going to find B. So B is the square root, and again, I'll read it right off the diagram. 1, 2, 1, 2, 3. So 2 squared plus 3 squared, which is the square root of 13. And now I'm going to find C, which is the square root of 2, 3. So 2 squared plus 3 squared, which is equal to the square root of 13. And so now, if I want to figure out which angle is 90 degrees, I know that the largest angle is across from the largest side. So therefore, A is the largest length. So therefore, angle A. So since A is greater than B and A is greater than C, angle A must equal 90 degrees. And again, a nice variation to this problem is, we give you a triangle and say, is it 90 degrees? And in which case, you would have to then, to check if it's 90 degrees, you'd say the square root of 26 squared is equal to the square root of 13 squared plus the square root of 13 squared. So therefore, 26 is equal to 13 plus 13. So 26 equals 26, and this nicely proves that, in fact, this is a right angle triangle. So remember, when you're doing a problem, don't just think about the problem that's being asked. Always ask yourself, how could it be slightly twisted? So this problem could be slightly twisted by saying, here's a triangle, is it a 90 degree triangle? Now the other way you could go about actually showing that this is 90 degrees is you could use a slope argument. And actually, in this question, we know it's 90 degrees. If we want to find the 90 degree angle, we could use a slope argument. So I've drawn my diagram, and based on the diagram, I would guess that angle A is 90 degrees. So what I'm going to do is I'm going to find the slope of BA. And the slope of BA we can see is rise, so it's negative 2 over the run, which is 3. And I'm going to find the slope of AC. So this is rise, which is 3 over 2. And I notice that since the slope of BA is equal to the negative reciprocal of the slope of AC, angle A is equal to 90 degrees. So that's the other way I could go about and do this. Okay, second part of this question says find the area. Now, I'm going to find the area in a couple ways. I'm first going to find the area in what I think is the most efficient manner. And so what I notice right away, we're going to find the area. What I really like about this problem is the following. I really like the fact that this is a right triangle. Since it's a right triangle, it's very easy to find the height as long as I choose as long as I choose the right base. So what I mean by that is, remember, the height of a triangle is always going to be you always find it by going from the base and following a line that intersects at 90 degrees from the base. So with a right angle triangle, as long as I take the sides that aren't the hypotenuse, I can find the area. So the area of this triangle is going to be 1/2 length C times length B. So that's going to be 1/2 root 13 times root 13. Again, you could now plug this in your calculator, but I think in this case it would be really nice to make sure you understand how to do that math there. Root 13 times root 13 is going to be 13. A nice way to go and prove that to yourself is think about taking, for example, root 16 times root 16. We know the square root of 16 is 4, so you can do some interesting stuff there. Let's just scroll over this way for a bit, and let's talk about a couple other little ways you could figure the area of this triangle. So, again, in fact, you know what? For the sake of this discussion, let's make a whole new triangle here, because let's do this triangle here. I'm just going to put a couple points. Let's put a point there. Let's put a point here. I don't know, and let's put a point here. There we go. Here's a triangle. Now I really have just made this up, and actually I think I've accidentally made up a 90-degree triangle again. So let's look. Let's see if I've made a 90-degree triangle without realizing it. 1, 2, 1, 2, 3, 4. 1, 2, 3, 4, 1, 2. So I've made a 90-degree triangle. Let's try again. Let's go to, I don't know, let's go to here. That doesn't look like, actually, let's go to here. That doesn't look like 9 degrees now. So here's a triangle. It looks like it's 9 degrees, but I'm pretty sure that this one isn't. And again, we could check that using various techniques. But what I want to get at now is that here's the thing. To find the area of the right triangle here is quite straightforward, but to find the area of the non-right triangle is a little bit harder. So one thing that we could do here is we need to find the height. So what I want to do is I have to pick one of these lengths at random to be the base. So let's name this let's name this triangle DEF. So if I have a horizontal or vertical side, that's usually the best one to choose as my base. But let's choose, for the sake of this discussion, let's choose this length as my base. If I choose this length as my base, what I need to do is to find the height. And to find the height, I need to drop a perpendicular straight down from that point E. Now, it looks like it might pass through this point here, but what I really want to stress is that, notice this doesn't cross through the midpoint of DF. The only time this perpendicular would go through the midpoint of DF is that if that triangle DEF was in fact isosceles, but it's not. So in this case, to find the length from E to, and let's call this point G just to help our discussion, I would have to find the shortest distance from a point to a line. But here's the cool thing. There's an easier way to find the area of a triangle. And then this works for any triangle you have drawn. We can think inside or outside of the shape. So if I take this triangle, and what I'm going to do is I'm going to draw a line, that kind of a horizontal and vertical lines that pass through each of the vertexes. I typically talk to myself a lot while I work. So now it looks like I've put this triangle inside of a box, but what I see right away is that I have 3 right angle triangles. Isn't that nice? So even though triangle DEF is a little more challenging to find the area of, let's call this H, let's call this point I, and let's call this point J. What I can do is I can find the area very easily of DEH. So the area of DEH is 1/2 times, that's my phone, just one second. Okay, sorry about that. I had to pause it while I grabbed the phone there. So we have area of DEH is 1/2. And we can think of, because this is a right triangle now, I can see the base is 3, so that's 3 times, and 1, 2, 3, 4, 5. So that's 1/2 of times 15, which is 15 over 2. Now I can find the area of EIF, or EFI, and that's going to be 1/2, and the base here is going to be 1, 2, and the height's going to be 1, 2, 3, 4, 5, 6. 6, so that's going to give me a value of 6, and then I'm going to find the area of DGF, and so that's going to be 1/2 DJF, sorry, 1/2, 1, 2, 3 times 3, so that's 3 times 3, which is going to give me 9 over 2. So therefore the area of, and now what we're going to do is we're going to find the area of the entire rectangle. So that's going to be 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. Area of JHEI is equal to, I think I said 5 times 6, so that's 30. So therefore, the area of DEF is going to be 30 minus 15 over 2 minus 6 minus 9 over 2. And of course, then we can just do a little bit of algebra here. So 30 minus 15 over 2 is going to be 7.5 minus 6 minus 9 over 2 is going to be 4.5. So that's going to give me 30 minus 18, I believe, which is going to be 30 minus 18 is going to give me 12. And so that's going to be 12 units squared. So the point I want to get across, just to kind of finish up, I know we've moved away from this original question, but we want to watch for right angle triangles, isosceles triangles, equilateral triangles, because they make our work a little bit easier. So here, because this is right, it's very, very easy to find the area, because the legs multiplied together divided by 2 will give me the area. This other example here I drew, which is not right, and not isosceles, is harder to find the area. Though we could choose one of the bases and find the distance from the shortest distance from E to line segment DF to find the height, and that's going to involve a little bit of algebra. But a nicer way to do this is to draw a box around this entire shape. And then once you've drawn a box around this entire shape, you can then find the areas of those right triangles and subtract them from that box. I hope this video helped, and as always, whether you're my student or not, please feel free to ask lots of questions. Have a great day.